Hello, in this video we will be discussing the while loop. The while loop is a useful function. It's similar to the for loop, but instead of looping a known number of times, which is characteristic of the for loop, the while loop loops over a block of code an unknown number of times. The looping process is controlled by a logical check. If we have a look at the MATLAB help command for while, we see the function name, a brief description of it. I recommend you use this command help while or even help for when you're using these functions yourself, because it's pretty easy to forget how to use these functions when you're learning a language for the first time. So it's an important ability to learn during this subject to help yourself by using the help command in MATLAB. So help while shows us that we use the keyword while with the keyword end, and after the keyword while we have a logical expression. If this expression evaluates to be true, we're going to execute some chunk of code that we have put inside the while loop. This kind of looping procedure with an unknown number of loops is useful for calculations when we have numerical error, such as a calculation that is an approximation to some result. So if we're calculating a number repeatedly, at the start the error might be very large, but if we keep producing our calculation results, eventually the error will get down to a small value that we are happy with. So to demonstrate the use of a while loop, I'm going to show you a quick example and we will step through it in debug mode. This short example begins with a variable called sum, which I've initialized to be 0. It's useful to initialize variables just as we did in the for loop video, where I initialized a variable for force to be full of zeros. Likewise, I've created a variable called sum and a variable called count to be 0. This is useful because with a while loop, the expression that we evaluate to determine whether we are looping or not, it needs to have a variable inside it to perform a logical check. If we did not define sum up here and we wanted to do a while looping procedure on the variable, we would get nonsense results, because by the time this result is checked, there would be no such variable called sum. So we just define this to be 0, and I've defined a counter variable called count, because in while loops, unlike for loops, there are no counting variables, such as in the for loop video there was a counter variable called n. We don't have that facility with while loops, so it's often useful to construct our own counter. So that's what I've done here. So let's just get into the while loop. If we put a breakpoint here and execute the code, we're going to see, if we just clear this screen, we have sum and count to be 0. We're going to enter our while loop by checking if the result sum is less than 100. If it is, we're going to enter inside the while loop and execute this code. Eventually, as a result of this code, hopefully the value of sum becomes greater than 100, and at that point we will exit the while loop and continue along our way executing the rest of our program. So let's step into it and see what's happening. So we're inside the while loop, there's no change as such so far. Let's step again, and we see we've executed this line, and our count has the value 1. I'm doing this because as we execute this code, after each check of the sum variable, it's useful to see how many times we did actually perform a loop inside the while loop. So it's useful to construct your own counter. It's not always necessary, but it's a useful piece of information that may come in handy in the future. If we now step through, we've executed this line here. Now what I've done is I've produced a variable called ran, and it is actually going to be displayed, so I won't type it into the command line. Its value is 18.1472. The value ran is simply a random number that I've generated between 10 and 20. To do this, if we just look at this line of code, it's a departure from the theory of the while loop, but it's useful to investigate to understand this program. You'll notice the value of this code that is exactly the same as the code that is assigned to ran is actually producing a different result. This is purely because of the function rand, which produces a random number between 0 and 1. In this case, I've asked it to produce a single 1-by-1 array that is random. In other words, a single random number. Remembering a 1-by-1 array is the simplest array where, as I said, it's just a number. In order to produce a random number between 10 and 20, I've added 10 to the random number between 0 and 1. So if you think about that, it's going to be 10, always 10, plus some number between 0 and 1. So in that case, you would be going between 10 and 11. Now if we consider the multiplication here, I've multiplied a number between 0 and 1 by 10. So this means I'm going to have a number between 10, should I say a number between 0 and a number between 10. So if we randomly got 0, the number after it's multiplied by 10 would be still 0. If I randomly generated the number 1, the number after the multiplication by 10 would be 10. So if you think of the extremes, if we add 0 to 10, we get 10. If we add 10 to 10, we get 20. So as a result, we get a random number between 10 and 20. So if you think about what we're doing with the rest of the program, we're actually just adding a random number to the variable called sum. We're just repeating this program until our value of sum is greater than 100. So you'll see the value for the first random number was added to sum, which was initially 0, and that's the result. Count is now 2, or I should say if we step this line through, count is now 2, meaning we've done one while loop and we're now entering the second stage of the while loop because sum is obviously still less than 100. If we keep stepping through this guy, we print a new random number, execute that line, we see that sum is now 37. Again, if we keep stepping through, and in fact I'm going to continue the program and let it do its thing. It keeps hitting the breakpoint at the while loop. So the program is now finished, and we see after we left debug mode and I let MATLAB do its thing, it went along, executed this program as it would normally without any breakpoints stopping it, and it's displayed the rest of the random numbers it's generated according to this command I've issued here. I've put this in just because it's interesting to see what numbers MATLAB randomly generates. And we can see at the end we've eventually found that sum. If we look what it is now, it's 112. So when the sum went to 112 as a result of an operation here, it was checked up here, it was greater than 100, and so it exited the while loop, and the rest of the program was executed. As we can see, the rest of the program was merely displaying information to the screen for us, and so we have finished this while loop. We see it took 7 generations of a random number in order to reach 100 if we started from 0. So this is kind of like the basis of random chance games in computer games. Similar algorithms are used in electronic gambling. So random numbers are generated, operations are performed on those random numbers, and often a while loop can be used to check if a certain tolerance or a certain threshold number has been reached, such as in the game blackjack. If you repeatedly getting random numbers and you're less than 21, you're still in the game, but if you exceed 21, you go bust. So algorithms like this have previously been used in electronic blackjack. So if we just finish our discussion on the while loop, we see that there's no counter variable, which is an important difference from the for loop. You must do it yourself if you want to use one, and that the while loop is completely governed by this logical check up here. We can perform any logical statement in this while loop. So we can have less than, greater than, equal to, not equal to, and so forth. Providing the result of the logical operation is true, whatever code is inside the while loop is going to execute, and it's going to keep executing until this condition changes to false. That's about all we can say about while loops, so I encourage you to construct some yourself, and if in doubt, always remember help and while. The document page for while is given by this link, and if you look also, there's similar conditional statements that we've discussed previously. So that's the documentation for, if, switch, and so on. I encourage you to read these documentation articles because it's almost impossible to remember exactly how everything works, so it's good to refresh yourself with these articles every now and then.